A good GPU means a much better gaming experience, enhanced animation and graphics, and new opportunities for those working with AI or cryptocurrencies. However, a good GPU costs a lot. There are budget-friendly options for around $250, but you will face many new limitations with every cent you want to save. Let's investigate why GPUs are so expensive and why the price is always growing. What is a GPU? A graphics processing unit is a specialized processor designed to accelerate the rendering of images, animations, and videos. Initially developed for video game graphics, a GPU can perform thousands of complex calculations simultaneously, making it ideal for tasks that require high computational power, such as machine learning, deep learning, and real-time data processing. Are GPUs and graphics cards the same? GPUs and graphics cards are often confused, but they are not the same. A graphics card or video card is the entire piece of hardware that contains the GPU and all other components needed for it to work and connect to your system. In simple terms, the GPU is inside the graphics card, which is responsible for displaying images on your screen. How does a GPU work? Modern GPUs typically consist of a number of multiprocessors, each with a shared memory block, several processors, and corresponding registers. GPUs may work slightly differently based on their purpose, manufacturer, specific chip design, and the software used to manage them. However, there are some general characteristics. GPUs are designed to efficiently process large data sets through parallel computing. They contain numerous cores that can handle multiple tasks, such as shading, texture mapping, and matrix calculations, simultaneously ensuring fast and efficient performance. GPUs have high-speed memory called VRAM, which stores important data like pixel information, colors, and screen positions. Some of the VRAM acts as a frame buffer, holding completed images before they're shown on the screen. VRAM is dual-ported, meaning it can read and write data at the same time, ensuring smooth and efficient data flow. What are the different types of GPUs? There are three main types of GPUs. Discrete GPUs are standalone graphics processors separate from the CPU, central processing unit. They're perfect for high-performance tasks like gaming, video editing, and 3D rendering. Discrete GPUs connect to the CPU via PCI Express slots, delivering powerful performance for advanced applications. Integrated GPUs are built directly into the CPU or system infrastructure. While they're not as powerful as discrete GPUs, they're energy efficient and ideal for laptops and systems that need moderate performance for everyday tasks or light gaming. Virtual GPUs are software-based and run in cloud environments. They offer the same capabilities as physical GPUs but without the hardware. This makes them cost-effective and easier to maintain, perfect for scalable workloads like virtual desktops or AI training. Why are GPUs so expensive? GPU prices are high mainly due to strong demand outpacing supply. Initially driven by gamers, demand surged further from cryptocurrency miners who required powerful GPUs and often purchased them in bulk, regardless of cost. More recently, AI companies have entered the scene, ready to pay premium prices for the computational power GPUs offer. Moreover, Nvidia's dominance in the market plays a significant role. Its QHEA platform has become the industry standard for AI and parallel computing, leaving little room for competitors like AMD and Intel to offer viable alternatives. Other factors contributing to high GPU prices include significant R&D costs for developing advanced GPU architectures, complex manufacturing involving cutting-edge technology, skilled labor, and costly materials, advanced features like ray tracing, AI acceleration, and superior parallel computing, which increase engineering costs. Manufacturers invest heavily in maintaining software ecosystems, including drivers, libraries, and tools, to enhance GPU performance and usability, adding to the overall expense. Global supply chain disruptions, semiconductor shortages, and limited production capacity that have strained availability. Import duties, tariffs, and regional taxes on components or finished GPUs. Rising wafer costs from TSMC, which manufactures AMD and Nvidia GPUs, have also contributed to higher prices. Subscribe to our YouTube channel, and we will help you make the most of technology.